Hello everyone, my name is Noah Kolander, and I'm currently investigating the effects of various giant kelp preservation treatments on the growth of juvenile red abalone. So to begin, the juvenile red abalone pictured here, along with all 7 species of abalone that are found in California, have been harvested both commercially and recreationally for thousands of years. Unfortunately, due to the intensity and longevity of this fishery, it has led to a decline in all 7 populations of abalone found in California. Currently, the red abalone is widely aquacultured and is sold around the world as a major and preferred human food source. In addition, the green abalone are also aquacultured, although at a fraction of the frequency, as they are mainly raised for research purposes and restoration purposes. While they're in hatcheries, they're commonly fed a diet that consists of giant kelp, pictured here, as one study found that it actually yielded the most growth in the abalone that it was fed to. Unfortunately, this fantastic food source is not always available throughout the year. Seasonally, in exceptionally warm summers or through an El Nino event, the surface temperatures of the water can rise to such a degree that it'll cause the kelp to actually die. In contrast, in the winter times, during rough storm action, it can actually cause the kelp to be ripped off of the bottom of the ocean and drift away. So with this in mind, it's important to determine if the long-term preservation and storage of kelp has any effect on the abalone's growth when it is fed to them. So currently in hatcheries, the abalone are fed this fresh algae. There are some hatcheries that have experimented with dried and frozen prepared algae, but they don't know if that causes any changes to the growth of the abalone. There's some hatcheries that have also experimented with a pelleted feed, but currently it's not widely produced and it's hard to acquire. So the smaller hatcheries that have to rely on weekly kelp collection, it just doesn't make sense for them. It's difficult to get out to the ocean every single week and collect fresh kelp. So we actually ran into this problem over the summer. A lady came to us asking if we would be able to raise up some green abalone for a restoration project. And so we didn't know if we would be able to meet those weekly kelp collection requirements, and so we asked her if we could use perhaps dried or frozen kelp and just store it when we were able to gather it. And we both didn't know if there would be any change in the growth of the abalone if we fed them this. So I developed this project to test just that. The objective of this project is to determine if the feeding of and exposure to variable giant kelp preparations will alter the growth of red abalone. So what I did was every single week, I would go out to the beach and collect kelp. I would then take a blade of kelp and prepare it in the lab. To do this, I would remove the tip and the nematocyst from the piece of kelp and then cut it into pieces. Those pieces would then either be dried, frozen, or stored fresh in the lab. Those prepared pieces would then either be placed into a scent exposure treatment, allowing the abalone to smell the kelp without being in the enclosure with them to feed on, or it would be placed directly into the abalone enclosure for them to feed on. Regularly throughout the project, I would record the weight and the length of the abalone. Additionally, I would also measure the consumption rate of each individual abalone. So for a general description of what my project looked like, up above we have this header tank, and down below we have the abalone enclosure. Water would be pumped into the header tank, which will fill up and then spill down into the abalone enclosure, which will then fill up and spill over the sides into a common water bath. Up in this header tank, we have our scent exposure kelp, which is stored. So as the water gets pumped into this, it'll mix with the kelp, infusing the water with the scent of this kelp, which will then be delivered to the abalone below. In the abalone enclosure, there will also be a piece of dietary kelp that is placed for the abalone to directly feed on. So for a broader, more all-inclusive idea of what my project truly looked like, pictured up here we have a header tank. So this is our first header tank. This has the dried kelp exposure treatment in it. So pieces of dried kelp were placed in there, the water infuses with the scent of it, and then it's delivered down to a dietary treatment. And in our dietary treatment, we have fresh-fed abalone, frozen kelp-fed abalone, and dry kelp-fed abalone. And in each of these dietary treatments, we had 8 replicates below in each of the different preparations. We also had a frozen exposure, and we had a fresh kelp exposure. So with this, we have a fully crossed design exposing every treatment fed abalone to all of the scents of the kelp and giving them the dietary treatments of the kelp to feed on. So this is what my actual project looked like. Up above, we have the Home Depot buckets, and then down below in each one of those little red solo cups, we have an individual abalone. All in all, I had 72 abalone that I was feeding every single day throughout this project. So as far as measurements go, I would remove the abalone from their enclosures, and then I would weigh them and also measure their length. I did this 6 times throughout the project, and each time it took 4 to 5 hours, so I'll spare you the rest of the video. So here we have our first abalone, our beautiful abalone number 15. If you look at this yellow circle right here, you can see the first aperture that's beginning to close. 4 weeks later, when I took another picture of it, it's almost even more closed. And then as we go on, and with every 4-week increments, you can see the leading edge that is being produced on the outer edge of that abalone growing more and more shells. So we can actually see it visually just week to week to week. We also have our beautiful model 37 abalone, which we can see a pretty cool feature of the abalone where whatever algae color it is eating, it will produce in its shell. So you can see here it was eating some sort of red algae, and then this stark line right here represents the point in which we started feeding it giant kelp. So we can see our own growth in it. So in addition to the weight and length, I also measured the consumption rate. To do this, I would photograph a piece of kelp next to a scale bar, and then I would place it into the abalone enclosure. After 24 hours in the enclosure, I would remove it and take another photograph. I did this 4 times. Every 24 hours, I would remove it and take another photo. So then I finally had like hundreds of pictures of kelp on my computer. So I uploaded them into ImageJ software analysis, where I then converted the image into an 8-bit photograph. And then I adjusted the threshold to sort the picture into only black pixels and white pixels. And then using that scale bar, I was able to draw a little box around the kelp that I wanted to look at. And then ImageJ would then convert the pixels into square centimeters. So using that, I got the very accurate estimate of the surface area of the piece of kelp at 38.582 square centimeters. So a lot better than me just looking at it and estimating how much had been eaten. Here we have the kelp that was fed to abalone number 79 at 0 hours, after 24 hours of grazing, 48 hours, and finally at 72 hours with almost nothing left. So after 22 weeks of exposure and dietary treatments, I compared the growth of the different abalone treatments using a 2-way ANOVA. This is what I found. So in this first column here, we have the scent exposure treatments. On the y-axis, we have plotted the addition of length, and on the x-axis, we have the variable kelp preparations. So as you can see, the shared letters above each of the bars indicate statistical similarity, or in other words, no effect. So whether the abalone were exposed to the scent of dried, frozen, or fresh kelp, they had no changes in the addition of length of their shell. Down in the second panel, we have the addition of mass. So once again, on the y-axis, we have the addition of mass in grams, and on the x-axis, we have that similar variable treatments. On the second one, we also have the shared letters indicating statistical similarity across the board or no effect. In this right panel, we have the dietary treatment, so the pieces of kelp that were placed into the enclosure that the abalone fed on. In this top panel here, we have, once again, statistical similarity, no effect. Finally, in this last panel here, we have our first significant difference. The abalone that were fed frozen kelp gained significantly less weight, although there was no statistical differences between the abalone that were fed dried kelp. In addition, when looking at the consumption rate of the abalone over the 72 hours that they were in the enclosure, in this first panel, we have the scent exposure. So abalone that were exposed to the scent of frozen kelp appear to be consuming their kelp at a faster rate than the dried and frozen. In this right panel, we have the dietary treatment. So the abalone that were given pieces of frozen kelp tended to consume their pieces of kelp very quick, or to a more complete standard than the other treatments. Although, as you can see by these error bars, there was a lot of variability in the consumption of the kelp, so it's difficult to exactly tell what's going on. So what we found from our scent exposure trial, we found no difference in that. So this is important because at the beginning of our trial, we were trying to figure out how we should set this up, and we were initially going to put all of the abalone in a common water bath and then isolate them in just mesh containers, one next to another, and we didn't know if the proximity of if we had one fresh-fed abalone here and one dry-fed here, we didn't know if there would be any interactions between those. Maybe the dried kelp smells really bad to the abalone, and then it doesn't want to eat. So we didn't know if that would affect it in any way, and from this experiment, we can tell that it did not. In the dietary treatment, we did see that the dried kelp-fed abalone did not differ in either the addition of mass or the addition of length, implying that this may be a safe alternative to feeding fresh kelp to the abalone every week. We also tested using our two-way ANOVA for interactions between the treatments. So we exposed them to the fresh kelp or dried kelp or frozen kelp, and then we also fed them the different treatments. So we crossed all of these across, and then we looked to see if there were any interactions. So if they were fed dried kelp and exposed to frozen kelp, or fed frozen kelp and exposed to fresh kelp, then we would be able to tell if they kind of influenced one another, and we didn't find any significant interactions. And the one thing that we found in the percent consumption that may have determined why the frozen kelp was consumed at the fastest rate would be in a separate trial off to the side. We had that kelp sitting in a dish without any abalone feeding on it, and the natural degradation of that kelp was more rapid than the other ones. So coupled with the abalone feeding on it, this may have caused our percent consumption to more be coupled with degradation as opposed to just straight consumption of the kelp. So the implications behind this. If abalone hatcheries no longer have to rely on weekly kelp collections to feed their abalone, they'll be able to develop kelp stores. With these kelp stores, they will be able to feed their abalone all throughout the year without having to go out and doing kelp collections, even in time of kelp scarcity when they can't find any kelp. This should also minimize the collection cost and frequency that the abalone hatcheries will have to go out and collect all this kelp, and then allow for a more functional non-commercial hatchery. So working at the CUI Marine Lab, we had this problem. During my study, I was trying to go out to the beach and find kelp, and some weeks I just 6 hours on the beach looking for kelp, and I couldn't find any. So this is very useful information to have. In future studies, our largest abalone grew to be only 60 millimeters, and as they have the ability to get up to past 300 millimeters, they still have a lot of growth to do. So we'd like to continue the dietary portion of the experiment to see if there's any further effects. And then we'd also like to do a cross-species study. This project is done with red abalone as they were easily acquired, but soon we'll be working with green abalone, so it'd be interesting to see if there are any differences between the red abalone growth rate and then the green abalone growth rate. Finally, I'd like to acknowledge Dr. Sean Benyami for helping me on my project with all the edits. Nancy Caruso, she was the one that supplied me with all of the abalone from the cultured abalone farm and came up or kind of helped us develop this project idea in the first place. Thanks to Jeff Landsman and Daryl Dulesky, when I couldn't find any kelp down here on the beaches, they would actually collect it up at Cabrillo Aquarium, and then Daryl lived down here, so he would drive it down for me, and he saved the project. And lastly, I'd like to thank the CUI Marine Lab volunteers for helping keep the lab clean and my abalone happy.